Look at the canyon walls framing Lake Mead. These stark white lines cutting across the rock are the most visible symptom of a slow-moving crisis. These are bathtub rings, physical mineral scars that mark exactly where the water level rested before decades of steady, relentless depletion. Lake Mead operates as a massive engineered reservoir, designed to act as a high-capacity savings account for the Colorado River. To build that bank, the United States spent the 1930s pouring millions of tons of concrete into the Black Canyon to construct the Hoover Dam, backing up the river to hold years' worth of flow. Today, the water held behind that dam sustains 25 million people, multi-billion-dollar agricultural industries, and the electrical grids of 4 states. Its decline threatens the physical survival of the entire American Southwest. Modern infrastructure built to interact with the lake is now entirely disconnected from it. Marinas and boat ramps sit stranded on dry mud, far from the current shoreline. Markers placed where the water level rested just 2 decades ago now stand high up on arid hillsides, providing undeniable proof of a continuous downward trend. The American Southwest has been operating on a structural water deficit for decades, relying on a mathematical impossibility that is finally coming due. The crisis at Lake Mead is the result of a broken equation. The first half is a severe, sustained reduction in the natural water supply feeding the system. This map outlines the Colorado River Basin. Most water reaching Lake Mead originates high in the Rocky Mountains as winter snowpack, but a 20-year megadrought has drastically reduced this snowpack, meaning significantly less volume flows downstream into the river. Simultaneously, rising temperatures are baking the environment. Hotter air absorbs moisture from the soil and accelerates evaporation directly from the surface of the lake. Between the lack of snowpack and the intense heat, the natural deposits into the region's water bank have collapsed. The other side of the equation is the explosive increase in human demand. Over the last 20 years, population centers across the Southwest have seen aggressive expansion, pushing massive suburban developments and sprawling infrastructure deep into the desert. Yet the primary drain is agricultural. Massive farming operations pull enormous volumes of water to grow water-intensive crops like alfalfa in an arid landscape. This combination of booming urban populations and heavy agricultural reliance requires consistent, heavy withdrawals that the shrinking natural supply can no longer support. This imbalance takes a physical toll. Dark stains on the Hoover Dam's concrete intake towers show exactly how far the surface level has dropped. Fallen water levels approach a critical threshold known as dead pool. When the surface drops below the dam's lowest intake valves, water flow downstream halts. Without water moving through these intakes, the massive turbines stop spinning, and hydroelectric power generation ceases. Hitting the dead pool threshold means the catastrophic failure of reliable water delivery to millions of people across the entire Southwest, and the sudden loss of a major source of electricity for the regional power grid. To keep the system from reaching that point, federal and state governments are attempting to forcefully correct the math. This graphic outlines the intense allocation negotiations taking place across the basin. California, Arizona, and Nevada have been forced to accept mandatory shrinking water quotas. Local municipalities are also rushing to implement strict conservation rules and build expensive infrastructure designed to capture, treat, and recycle every possible drop of water used in urban areas. These policies are essentially triage operations, attempts to ration a vanishing resource to delay the collapse of the system. Climate scientists warn that the underlying cause of this deficit is a permanent shift in the regional climate. Experts describe this as aridification, a transition to a drier baseline climate that replaces the temporary drought cycles of the past. This chart models the trajectory of Lake Mead's water levels over the coming decades. If demand continues to outpace the new, lower supply, the basin's capacity faces a steep, unrelenting decline toward zero. The Hoover Dam is a monumental engineering achievement, but without enough water to power its turbines or fill its penstocks, this massive legacy of infrastructure is at risk of obsolescence. Securing the region's future demands a total structural reimagining of how society lives, farms, and builds in the American West to prevent ecological bankruptcy.